Hello. I think I've got the board back to where we were. Um, what have we got? I think I had just put blue in. You could do. I double checked, and I think that's what happened. I put blue in, but I hadn't updated next to put yet. Every time we put something in our bounded buffer, we increase the next to put index by 1. Except look what happens. If I increase that by 1, that goes up to 5. There is no slot 5. So here comes the circular nature, the wraparound thing. We don't leave this at 5. When it gets all the way up to 5, we reset it to 0. So now, the next to put is going to be here. Except that's also next to get. That slot is occupied. So when we try to put indigo, we can't. The buffer's full. Somehow or another, we got to test that. It looks like we ought to be able to just check and see. If next to get and next to put, if they overlap each other, then this is completely filled up and then wrapped around back to the first one, or whoever the next to put is. So whatever the reason, that's no. That should get a false back. Same thing here. If I try to insert violet, it's still no. No movement on either one of these because the next to get is still going to be red. The next to put eventually, once there's space, will be 0. So let me see if we can even go through the rest of these. Violet, that's a no. That'll get a false value. Remove. Remove looks at next to get, ignoring next to put. Next to put, we only use that in the put operation. Next to get, we'll only use that in the remove operation or the get operation. So next to get, if that's 0, then that means that's where it comes from. There's red. Red is used up, and this needs to now be incremented. And look what happened. Just reflecting about this in the meantime. Once we get one thing out of there, then we now do have a place where we can put something, and next to put is already updated to show us that that's where it will go. So let's see. Let's do another remove. Take out the orange, send it back. I hope I don't forget these. I've got to update this next to get. I've already gotten from slot 1, so now I'm ready to get from slot 2. Next remove, get yellow. Yellow comes out, return yellow. Update this. The next one to get will be from slot 3. Remove. Remove, we'll get green, because that's where the next to get tells me to get the next thing. And it returns true. Yes, I got you something. Here it is. Yes, I got you something. Here it is. Did you hear that? This equipment, I don't even know if it's going to last through summer school. I had a big enough break trying to get stuff put back together for the second piece of this video that I had time to eat lunch, and it still was broken. Okay, now am I caught up? Next to get green, no it isn't. We've already gotten green. Next to get should be up to 4 now. So the next thing to get will be blue. The next place to put is here, the vacated slot by red. Now I can insert. And my test, tentatively my test is, if those two things are equal to each other, then what? There wasn't any room? Isn't that what we looked at before? When the next to get wrapped around and was equal to, next to put wrapped around and was equal to next to get, then the buffer was full. So when they were both 0, the buffer was full and I couldn't do anything. So insert gray. Now there is place to put something. Next to put says 0. So I'm going to put gray at slot 0, overriding the red. Now I mentioned that earlier. There's no reason to set this to the empty string or some kind of garbage or whatever. Maybe for debugging, but it's actually a little bit inefficient to set red to anything. We've already returned it. We've already bumped up the next to get index, so we're leaving red behind. Now we overwrite it because we need that slot again. So gray goes where red was. Check, that was successful, even though these two inserts up here were not. It's easier, you know what? It's easier to just do this and think about it than it is to try to do it and think about it and talk about it. So I hope I haven't misled you, particularly with my technical difficulties going on here. But am I up to date? Next to get is 4. Yeah. Next to put, nope. I've got to update that. Next to put will now be 1. And we'll overwrite orange with pink when this insert comes along, insert pink, yes, we can insert pink. It goes in slot 1. And this needs to go up to 2. Now, let me take a snapshot. Let's examine the state of the object. First of all, you'll notice that printing out the array, it might do more harm than good. It's going to be very confusing. It looks like that gray is at the front of the line, but it's not. Blue is at the front of the line. The next thing to get will be blue. And gray, pink, and if we print it out as is, it's going to say gray, pink, yellow, green, blue. Completely misleading. You can't tell who's next. You can't tell who's most recent, any of that stuff. Let's keep going and use up the stuff in the buffer intentionally. I am kind of making this up as I go along. Remember, I'm trying to, so long ago that I said this, I'm trying to emulate what you might be doing in scratch work, trying to figure out, well, how do I keep up with all this stuff? What's in the buffer and what's not? Where's the next thing that I get? Where's the next place I put something? So I'm going to continue on with just more operations up here. And let's see. We haven't done what? We haven't done a remove in a while. I'm going to do a remove operation, just see what I get. Am I going to get anything? Yes, the next to get is 4, slot 4, and there is a blue, so I get blue. Now here comes the wraparound again. The next to get, that's also moving from left to right through the buffer. So when I bump this up to 5, I can't leave it at 5. I can't get something from slot 5 because there is no slot 5. So 5 is out. Whenever it goes as high as 5, when it reaches the size of the buffer, then I need to reset it to 0. And that makes sense. After blue in line is gray. These were unsuccessful. So after blue, the next successful insert was gray, so that's the next one that should come out. So let's do some more removes. I'm going to do remove, remove, remove. 3 more. Oh, I forgot to mark out blue. I told you, it's hard for me to just keep up with all these different pieces. Remove, remove, remove. Remove. Remove gets from next to get. That's going to be slot 0, so it gets the gray. Bump that up to 1. The next to get is now pink. So when I call remove again, I get pink. And that gets bumped up to 2. When I do remove again, there's nothing in here that hasn't already been gotten. These have already been taken out. And look, our test is valid. Those two are equal to each other, so the remove is going to fail. But now wait a second here. That was a test for something else, wasn't it? That was our test to see if the buffer was full. If I filled up the buffer and then the next to put wrapped around to slot 0, I would say, well, look, we could use that to check. If next to get and next to put are equal to each other, then the buffer's full, the buffer's empty. Here's a weird thing. If we had the luxury of several more weeks, and you had the luxury of time to do a bunch of examples, you would probably discover on your own, oh, I take that back, you would definitely discover on your own that next to get and next to put are going to be equal to each other in both of the boundary conditions. When the buffer is completely full and the buffer is completely empty. So it looks like all hope is lost. How are we ever going to know which one it is? Because it does make a difference. This means that the remove operation is going to fail. What it meant before, way up here, was that the insert operation failed. So it's not going to be a reliable test to see if those two things are equal to each other, to know whether the buffer is completely full or completely empty. Here, this failed because the buffer was completely full. Here, this failed because the buffer was completely empty. Oh, woe is us. Looks like we can't do anything. I'm going to erase this again. Here's the problem. Even though it's necessary for next to get and next to put to be equal in both of the boundary cases, next to put is equal to next to get when the buffer is full, but that's not a sufficient, that's not, yeah, that's why I was the right word, and I'm just going to change it. That's not a sufficient condition to tell us when the buffer is full. Back at the very beginning, here we go again. I'm going to see if I can use the same example to see if we can fix it. Maybe third time is charm. We won't have to go through any more. If I can get all these reconstructed the way they were. There, back to the drawing board. And now I'm going to re-put my remove up here that I took away before. Why? Well, up here, that remove failed. That last one up there, that failed because next to put it next to get were equal to each other. If this is completely reset, the buffer, I'm starting all over again. The constructor was just called. The constructor just now set both of those to 0. I can't check and see if they're both 0 to know whether or not remove is going to be possible because they're both going to be 0. Listen to this. If the buffer is completely empty or if the buffer is completely full. So there might be plenty of stuff to remove up here. Oh no, woe is us. You know what? It's trying to break through yet another state variable. Be very, very stingy about adding state variables to your class. Every time, here's a complexity issue, every time you add a new state variable to your object, to your class, it doubles the complexity of the code. Because you have to go back and think about how every operation that you've already done affects your new kid on the block, your brand new state variable. This one, I don't think there's any way around it. What should I call this? Buff. Because it's a buffer, I'm just abbreviating, buff count. I am going to need a separate variable that keeps up with how many things are currently in the buffer. It's not good enough to test to see if these two things are equal to each other. If I need to know if the buffer is completely empty, I'll check the buff count, and that will be 0 if the buffer is completely empty. Oh no, they're both equal to each other again. I can look at buff count. And if that is maxed out, if that's a 5, then I know the buffer is completely full. Now then, I'm going to go through this real fast so that you can do your own examples and see how all these variables are going to be affected. Whoops, I forgot already. If I add a new state variable, I need my constructor to take care of it, give it an initial value. Everybody's 0. Everybody's 0 for a different reason. This one's 0 because the very first thing I'm going to get out of the buffer needs to come from there. This is 0 because the first thing I put in the buffer has to go there. This is 0 because there's nothing in there yet. And if I keep these 3 straight, it's going to be a miracle. Let's see. Remove. Can't remove. How did I know that? Because I checked buff count. That's the only thing I need to check now. These don't tell me what I need to know. Remove fails because there's nothing in the buffer because buff count is 0. Already, our new state variable is earning its keep. Insert red. Okay, there is space. I've got to check. Is there space for red? Yes, because buff count is less than maximum. So I've got to do that quick check. I told you it's going to double the complexity of the code. Now there are more things I'm going to have to test in my member functions. I've got to check and make sure buff count is not maxed out. It is not. 0 is certainly less than the size of the buffer. There is space for red. Oh no, where do I put it? I put it in next to put, slot 0. Red. Now here's where things could get off track for me. Next to put needs to be incremented up to 1. One moment. Next to get leaves alone. It's not a player in this operation. Buff count needs to go up to 1. I hope I'm up to date. Try orange. Can we put orange in there? Our first check is the buff count less than 5? It is. It's less than the maximum. So yes, orange, you can go there. Where do you go, orange? You go in next to put. Orange. Check. I need to bump up next to put. It's now up to 2. The buffer count is now up to 2 because there are 2 things in there. It looks like these are always going to be equal, but I'll spoiler alert, they're not. They're not always going to be equal. Let's see here. Yellow. Let's put yellow in there. Is there room? Yeah, buff count's less than max. So yellow can go here. Because next to put told me so, that needs to go up to 3. There are now 3 things in the buffer. Check. Let's try green. Is there space? Yes, 3 is less than 5. Green goes in slot 3 because next to put said so. We bump that up to 4. Now there are 4 things in the buffer. You're in there, green. Blue. Is there space for blue? Yes. Buff count is less than the maximum. It's 4. There is space for blue. Where does it go? It goes next to put, right here. Blue. You're in there. The next to put, here's where they're going to diverge. Next to put needs to do the wraparound thing. When we bump this up, it'll go to 5, but you'll have to test. There is no slot 5, so this already has to wrap around, back around to 0. The next place we'll put something in the buffer is in slot 0, even though we can't do that right now. What else? Well, when I put blue in there, the buffer count, this goes up to 5 without wraparound. That's not an index number. That's telling me how many things are in my bounded buffer right this instant. So here, this snapshot, what have I got? I just now split these apart because next to put had to wrap around in the beginning of the array. Buff count is up to 5. So that was with blue. Here comes indigo again. Let's give indigo another chance. Look, our first test is this. We can only put indigo in the buffer if buff count is less than 5. We don't even have to look at these two. It doesn't matter that those two are equal. They were equal when the buffer was empty. That doesn't tell us anything. Indigo can't go in there because the buffer's full, and the buffer's full because buff count has made it all the way up to 5. Same thing with violet. Do the same check. Buff count is still 5. Nobody's been taken out lately. So, no can do. Remove. How do we know if we can remove something? Once again, we check with the buff count first. We check to see if there's anything we can get. This is coming in real handy, by the way. Is there anything to remove? Yes, buff count says there's gobs of stuff to remove. There's 5 things you can remove. So remove will be successful. It's eventually going to return true. The next to get comes from slot 0. We get red. Send red back. But before we do that, next to get needs to bump up to 1. And look what happens to buff count. Buff count goes down to 4. No wraparound. This is either going to go up by 1 or down by 1 for a successful operation. These have lives of their own, and they change values for different reasons, under different conditions, go to different values and so forth. You've got to keep up with this. The best way to get your mind wrapped around this, how am I going to write the code? Do example after example after example. And if you can't make it work, working it out by hand, you're not going to get the code to work. There's just no way. Lost my place again. Am I up to date? My next to get will be 1. Next to put will be 0. That's still okay. The buff count is 4. Do a remove. Remove, yes. Buff count is more than 0. Whenever buff count's more than 0, the remove operation will be successful. 4 is definitely more than 0. Where do I get what I'm going to get? I get it from next to get, which is 1, orange. Got from there, got. Next to get is now up to 2. I'm actually writing this too soon, and I regret that. I'm sorry. These things have to be updated before we're ready to send whatever we got out of the buffer back to the main program. So this orange doesn't come back from the remove operation until all the state variables have been updated. If we don't do it then we've lost our chance. Snapshot, are we okay? The next thing to get will be yellow in slot 2, yes. The next thing something will go will be to overwrite red, yes. Okay, the buff count, is that up to date? No. I forgot to update that, sorry. When I do the remove and take orange out, then I bump down the buff count, and it's now gone down to 3, because there are only 3 active things left in the buffer. Do a remove again. Let me see if I can get this one right the first time through. Can we successfully do a remove? Yes, the buff count is more than 0. Where do we get what we're going to remove? From the next to get index indicator. It says 2. You want to get yellow. Mental note. Let's get yellow. But before I send it back, here's where I got things out of order before. Before I send things back, I need to bump this up. And I'll also need to check and see if that's gone off the end of the array. In which case I'm going to have to wrap it around to 0. This did not go off the end of the array. Since I'm getting something out of the buffer, I also got to decrement that. We're now down to 2 things left in the bounded buffer. Now I send yellow back to the main program. The main program says, oh, look, we got yellow. Try that again. Can we successfully do a remove? Yes, we can. Buff count says there are 2 things in there. So let's go. We're in business. Where are we going to get it? We're going to get it from next to get. That's slot 3. That's going to be green. Need to bump up next to get, and we need to check. Is that equal to the size of the buffer? If it is, we've got to wrap around to 0. Tis not. Next to get is still moving up. We've got the green out of there, and the buff count is now down to 1. Let me double check and make sure everything's consistent. The next place we will get something is slot 4. The next place we'll put something is slot 0. The buffer count is currently 1. I know this is a mess. There wasn't room to make that one column. But the buffer count is only 1. There's only one thing left in the buffer. Can we insert gray? That says gray. We check and see. Is there room? Is buff count less than 5? Is it less than the size of the buffer? Yes. 1 is less than 5. There's room. This operation will be successful. Where do we put it? We put it in next to put. Gray goes right here. Got to update. Next to get is untouched. Next to put goes from 0 up to 1. That's the next place we'll put something. The buffer count goes from 1 up to 2. There are 2 things in the buffer, and it doesn't look like it, but they're next to each other. Blue is in the front of the line. That's the next thing we're going to get. After that, when we do the wraparound, gray is behind blue in line. It looks like it's way in front of it, but it's because of that weirdo wraparound. Gray is actually behind blue in the queue, and it rhymes. And gray was inserted successfully. Can we insert pink? We check and see. Is buff count less than the max? Yes, it is, so we can insert pink. Where does it go? Next to put is slot 1. It goes right here. Pink. Let me catch up. Next to put, we use that, so now we go up to 2. 2 is the next slot where we put something, and buff count is still going up, that one up to 3. Next to get is untouched. Did pink. Now, this is such a mess that I'm going to put dots in a 4 right here. This will be dots in a 2. That's the current value. And that history was just for us anyway. The computer can't see any of that. All that's long gone. And this is currently 3. Let me double check before I start the operations at the top of the board. 3, 2, 3, 4. Different values for every single one. Why is next to get 4? That's the place where we'll get the next thing that's waiting in line. Why is next to put 2? Well, that's the next available slot that's currently unused of where we can put something with an insert operation. Why is buff count 3? There are 3 different values currently stored in the buffer. See how that works? Those are all 3 legitimately different from each other for very different reasons. Remove, can we do a remove? We check buff count first. Yes, that's more than 0. We can do a remove. So we're going to get it from next to get. Slot 4. Blue finally has its day in the sun again. Blue got. Buff count will go down to 2 when we get blue. And next to get does the wraparound thing. It temporarily goes up to 5, and then you test it and say, well, no, you can't stay at 5. You got to go back to 0. Am I up to date? 2 things in the buffer, yes. The next place to put something is slot 2. Those 2s are very different from each other, by the way. The next place to get something is slot 0 because we've wrapped around. We got blue off the tail end, so gray will be next. That's what we get. We check with remove. Yes, there are 2 things left. We get the gray. I'm doing it in the wrong order. I'm sorry. We got it out of the buffer. The next to get will now be bumped up to 1 because we just now got what was in slot 0. Next to put is untouched. Buff count goes down to 1. Getting perilously close to a boundary condition. Remove. Can I remove something? Yes, buff count is more than 0. As long as it's anything more than 0, it means there's some active stuff in the buffer. Let's get whatever there is to get. The next place to get something is slot 1. We get pink. When we get pink, the next to get will go up to 2. The buff count goes down to 0. And look, boundary conditions, completely full, completely empty. Sure enough, next to put and next to get are both 2. But when we try to do this remove, that's not what we check. Because this doesn't tell us whether the buffer is completely full or completely empty, but this does. The buff count is now down to 0, meaning everything that was in the buffer has been gotten. It's gone. So this is going to return false. Do these even make sense anymore? Well, that certainly makes sense. There's nothing left in the buffer. The next place we're going to put something is slot 2. So if another put operation comes along, that's where it will go. And since the buffer is empty, that's the next place where we're going to get something. Whatever just got put in slot 2, that'll be the next thing we get. So yeah, it does hold water, logically, so to speak. Please use this as a starting point. These were the things that I was hoping, in the longer, more stretched out, thoughtful semester where we sit around and drink coffee and discuss bounded buffers. These, I'm sure you would have come up with on your own. At this point, your job is to make sense of this. And I would say there's no substitute for additional exercise with this. Keep going. If you want to pick up where this left off, do some more puts, do some more gets. Make sure your understanding of when these go up, when they go down, when they wrap around at the beginning, all that stuff. If you don't understand why and when that happens, even though the code, once you get the code, you're going to say, this is what I spent all this time on. It almost dissolves into nothingness. It's actually pretty small. But even though it's pretty small, it's not going to be correct if you don't understand this. So go back and put some thought into this. Get your mind around this. And write that code. Good grief. And I'll see you online.